we're going to take a look at matter and its classifications. So a couple things first about matter. Everything in the universe is either defined as being a form of energy or a type of matter. So if it's a type of matter, remember it has a measurable mass and a measurable volume. Now, matter can be further subclassified into two categories, either as a substance or as a mixture. So what I'm going to do is I'm going to first talk about the substances. So substances are considered pure. And that pure has nothing to do with, hey, this is really good for you or anything like that. Let's talk about why substances are pure. A substance is considered pure because it's made up of one type of particle. So therefore, all the particles in the sample are identical. Meaning that if you compare every particle to every other particle, they will have the same composition, because they contain the same type of atoms, and they also have the same structure. Because all of those atoms are linked together with the same bonding pattern. So substances are pure. They're made up of one type of particle. All particles in the sample are identical because the composition, the type of atoms present, the structure, the bonding pattern are the same through the whole sample and between samples. So now, something that we'll talk about a little bit later in the realms of chemistry and substances, that if a form of matter or sample of matter is referred to as a solid, liquid, or as a gas, those phases in getting specifically in chemistry are reserved only for pure substances. Now, substances can be further classified as two more subcategories, terms that you are already familiar with, element and compound. So there are differences between an element as a substance and a compound as a substance. So if our sample is an element, it's because there is only one type of atom present, only one type of atom. So that's huge. Okay, so only one type of atom. So I want to write down some chemical formulas and maybe draw particle diagrams here. Okay, so let's start off with this. So we have the element gold, and its chemical formula is Au. If I was to draw a particle diagram of this, gold's chemical formula can be represented by one atom, so maybe I would just draw this symbol here. Now, another element that you guys are all very familiar with is oxygen. But oxygen's chemical formula, the oxygen that we breathe for our respiration, its chemical formula is O2. And I know many of you have seen this before. So a particle diagram for the oxygen, I would see two identical atoms touching or linked together. And now there's another element, phosphorus. And phosphorus, one of the ways that we find it naturally in nature is P4. So I would need to draw a particle diagram that would show 4 identical atoms touching each other. But in each of these chemical formulas, whether it's golds, oxygens, or phosphorus, there's only one elemental symbol present, meaning there's only one type of atom present. Now, compounds, okay? So if it's a compound, this means that in the chemical formula, there are going to be at least 2 different types of atoms. So I'm going to write at least 2 different types of atoms in a particle. So that's very wordy, I know. So if it's a compound, we have at least 2 different types of atoms in a particle. But the second part of that is that every particle, those atoms combine in a set ratio. So I'm going to shorten form different as just diff. Different atoms in a set ratio. And that is another huge idea. So we have that set ratio. So let's write down a couple of examples. So water. Okay, you guys know water's chemical formula is H2O. So in order to have water, H2O, you have 1 oxygen, and that 1 oxygen is bonded to 2 hydrogens. So every water molecule, no matter where you find it in this world, is going to be made up of 2 hydrogens to every 1 oxygen. If that ratio of 2 to 1 changes, it is no longer water. Let's put down another example, like table salt. So I'm going to put T for table, and I'm just going to write salt. Its actual chemical formula is NaCl. So here we go. We need 1 Na atom bonded to a Cl atom. So every NaCl is always 1 Na to 1 Cl. That's that set ratio. And they are 2 different types of atoms. So now what I want to do is now I want to go to the other side here, to mixtures. So mixtures are considered not pure. And that does not mean that it's unhealthy for us. Okay? Almost every type of matter that you and I rely on in our everyday lives is actually a mixture. There's very few substances that we use on a daily basis. So it's a mixture because the sample is made up of different types of particles. The particles within the sample are not identical. They're not identical to each other because they have different structures. So here we go. The composition can vary within the sample or between the sample. So composition can vary. Now, this is something we will talk about later on, but for a mixture, the most common phase that you and I will come across and we spend time on, it's a phase known as aqueous, Aqueous, and its symbol is AQ. And that just means that it is a water-based solution. So H2O-based solution. And if it's a mixture, we can separate those different types of particles by a physical process. And I am sure that without even realizing it, in different things you have done in your life, in the kitchen or laundry, cleaning your room, you have separated different types of materials from each other using common sense. Now, there are two major types of mixtures. And these mixtures are differentiated because they talk about particle distribution. So I'm going to write particle distribution. Now, we have one that's homogeneous or homogeneous and heterogeneous. So that prefix HOMO entails the idea of same, where HETERO is different. And we put those prefix meanings in front of particle distribution. Those prefixes describe the distribution within the sample. So if it's a homogeneous mixture, it means that it has a homogeneous or homogeneous distribution. So that means that you have we're going to say a uniform distribution of all the particles. So it's evenly mixed. Where heterogeneous, hetero means different, means we have a different type of distribution. So here there is no uniform distribution of the particles. It's unevenly mixed. And here's a clue that if you have to shake or stir the sample before you use it, it's a heterogeneous mixture. So if I was to just draw like maybe a picture of what equal or uniform versus not uniform, here we go. So I'm going to use blue and red. So here's my blue particles, one type of particle, and here they are over here. Right? Now, red particles here. So if I have a homogeneous distribution, the red and blue particles are as evenly spread out throughout the sample. But if I have a heterogeneous, different types of distribution, my blue particles do not mix very well with my green ones, and maybe we see some sort of layering going on here. So draw a simple picture to help you differentiate between homogeneous versus heterogeneous.